Hello again, you guys. This is the video for Unit 7, Topic 1, Day 2, which is still sample spaces, but the second day of it. So if you find your 7.1.2 notes, that's what I am going through today. So we'll go ahead and get started right away. A Venn diagram may be used to visualize a sample space and events. It may also be used to determine outcomes and combinations of events. Okay, to make a Venn diagram, start with a rectangle. The area inside the rectangle represents the sample space, or S. So we have Venn diagram. You can put that at the top of your page. Okay, this is a Venn diagram. Now that may not be what you are picturing as a Venn diagram, because most of the time you picture two circles, but not every Venn diagram has two circles. Okay, so a Venn diagram, if you're putting the definition down, is used to visualize a sample space and events, and it's used to determine outcomes and combinations of events. If you want to give yourself a drawing, what I would do is I would draw this picture here, and then I would draw in the fact that this is your event, that A is your event, okay, and this S here, this rectangle represents your sample space, okay? So those are your things that you have there. Everything that's in the white is in the event. Everything that's in the blue is in the complement of the event. So it says next draw a shape to represent an event. In figure 1, you see that the region outside of it is denoted as A to the C power, and that's the complement of A. So everything not in A. Okay, so realize that no matter what you talk about, you have a full sample space, and then you have events. We're going to get into this a little bit more. Again, the complement, your second word that's on your paper there. So we have a Venn diagram, and we also have our complement. Okay, just denote that it is A to the C. Okay, and it's every outcome not in the given event. Okay, again, I'll repeat that: every outcome not in the given event. Okay, so take for example the idea of rolling a die. So you have number 1 on your paper there. Okay. Think about drawing the sample space and filling in all possible outcomes, okay? So your sample space, again, usually you represent by a rectangle. So this whole rectangle represents your S or your sample space. So what's in this? If you roll a die, okay, there's one of them, then you have a 1, a 2, a 3, a 4, a 5, and a 6. Those are your possible outcomes that happen, and that's how we're putting our sample space into a Venn diagram right now, okay? So draw the sample space and fill in all possible outcomes. That's what we have there. If I then draw a shape that represents the event of rolling an A, or event A, of rolling an even number, so think about that. If you're rolling an even number, you have a 2, a 4, or a 6. Okay, so in this case, and this is where it gets kind of crazy, but I did this on purpose, is your event A is going to have to be kind of this shape here. Okay, so this is my event A. Again, the purple is my sample space S, and are representing what we have there. Okay. And then lastly, where is A complement? Where is A? Where is S? Okay. So if we're going to recognize all of these different things, I'm going to start with S. Okay. S is 1, 2, 3, 4, 5, and 6. Okay. And it's represented by the entire rectangle. Okay. If you talk about A, okay, A is just 2, 4, and 6. It's all of the even numbers, and it's represented by everything that's in that little squiggly shape that I made. Okay. And then if you talk about a complement, you're talking about everything not that's in the sample space, but not in A, then we're talking about 1, 3, and 5. And so this essentially is take the rectangle, remove all of that craziness in there, and A complement is everything that's not in that little figure. Okay, so those are our different pieces that we're talking about here, and that's with rolling a die. Okay, if you roll 2 dice, so you see number 2 on your paper, okay, let the sample space be the sum of the spots. So we talked about this a little bit yesterday, but the sum of the spots on the sides of the lambs face up. Let A be outcomes that are less than 6, okay? Here I'm going to start my Venn diagram differently. I'm going to start with the rectangle, okay? So I know that I have a rectangle, okay? And I'm going to draw a Venn diagram and a circle, and then I'm going to fill in the numbers, okay? Now, this circle is representing my event A, which is that the sums are less than 6. I have to think about rolling a dice. You cannot get a sum of 0. You can't get a sum of 1. The lowest you can get is 2. Now, less than 6 means I put 3, 4, and 5 in here. Okay, I do not put 6. It says less than 6. And then I'm going to put everything else in on the outside. Okay, so a Venn diagram to represent the sample space with event A and event AC. So that means that I'm going to put 6, 7, 8, 9, 10, 11, and 12 are all of my other possibilities on the outside of this one. Okay, we record the outcomes in S in the appropriate regions of your Venn diagram. So this is what we have that is here. Again, you can label this S, but your rectangle is going to represent your sample space. Okay, events A and AC using set notation. So set notation, capital A equals, use the squiggly brackets. Okay, your event A has the outcomes of 2, 3, 4, and 5. Okay, and then your event AC has all of the other outcomes. So anything that you have listed up here except for 2, 3, 4, and 5, you should have listed. And so that happens to be 6, 7, 8, 9, 10, 11, and 12 here. Okay, so that's your AC. Okay, so the next thing that you see on your paper is the information about intersections and unions, okay? And these are, again, ones that I'm going to highlight. I'm going to highlight the word intersection and the word union because we're going to be talking about those quite a bit, okay? An intersection, we have some notation we're going to use. You're going to see the notation of it's an upside down U, and union is going to be a right side up U. And they're capital, but they do not have any lines on the side of them, okay? So those are going to be the symbols that you're going to see. The intersection is the set that contains all outcomes that are in A and B. Okay, that and word is really important there, but that's what we're going to have there. So we want all of the outcomes, so anything that's in the sample space that is in A and B to be filled. And so my intersection is this right here. Okay, and if we understand what an intersection is, that should make sense in our Venn diagram. Okay, the union, we're going to use almost the exact same words, okay, but we're going to put an or in place of the and. Okay, so it's the set that contains all outcomes that are in A or B. Okay, so we have this word or here. So a few other things that I'm going to look to possibly highlight here is we want to make sure that we know that, and we know the or word, and we know this symbol, and we know the and word that goes with an intersection. So we're looking at those different words that are there. Now, what part of this is that? Okay, the set that contains all outcomes that are in A or B. So anything that's in A is in A or B. So that means that all of this would be true. Notice I did cover the intersection there, okay? But it can be an A or B, so that also means that anything that's over here can be true, okay? So the union is all of this together, okay? Think about the union brings it all together and everything that you see there, okay? So that's an intersection and a union. Okay, I want you to pause the video and go ahead and do the question at the top of your page. Work all the way through the dotted line that you have there. So it's question number 3 on your paper there. And talk about a supermarket. So go ahead and pause the video, do that, and then come back to this video. I'll take about a 5-second pause here. Okay, if you've done that, then you have this, you've read through this. A supermarket sells 3 types of milk, whole, reduced fat, and fat-free. So I'm going to call my whole milk W, my reduced fat R, and my fat-free F, just to refer to those and write them a little bit quicker. The manager is interested in customers' preference and records the milk selected by the next 2 customers. Okay, so determine the sample space for this situation. Use W, R, and F for whole, reduced fat, and skim milk. So you can see I'm doing that up there. Feel free to draw a tree diagram to help identify all possible outcomes if you need to. Okay, so what you're thinking about here, the random process, okay, is the fact that there's one customer walking in and choosing a milk, and then there's another customer walking in and choosing a milk. Okay, so if I'm going to do the sample space in this case, okay, the first customer, sorry, we're going to have some glitches here. Nope. There you go. The first customer that walks in can choose to have whole milk, and then the second customer gets to make a choice, and so I'm going to go with whole milk. Okay. Now the first customer could have also chose whole milk, and the second one could have chose reduced fat, and the first customer could have chose whole milk, and the second one choose fat free. So that's kind of the way that we're going. Now those are all of the possibilities of the first customer choosing whole milk. So then I'm going to go on to what if the first customer chooses the reduced fat milk. Sorry, I'm having some technical difficulties here. There you go. Okay, if they choose the reduced fat, the second customer could have chosen whole. Again, first is reduced fat and second one could be reduced fat. And then the third option is reduced fat and fat-free as your possibilities there. And then lastly, you need to add in what if the first customer chose fat-free. So it's fat-free whole, fat-free reduced fat, and fat-free fat-free. Okay, so those are all of the possible outcomes. Again, there are two random events that are happening here, and that's that one customer walks in and makes a choice, and then a second customer walks in and makes a choice. Okay, let A be the event in which both customers select the same type of milk. Okay, and let B be the event that neither customer selects whole milk. So we're going to do set notation here. So we're going to do A equals, and this is both customers select the same kind. So this is going to be your WW, your RR, and your FF. Okay, so there's three things in event A. Okay, and event B is that neither customer selects whole milk. So if I'm going through this first one here, I'm thinking about I want to get rid of all of the ones that have a W in them and only write what's left. And so that's going to leave me with RR, RF, FR, and FF, as you can see above. Okay, so that's what that red is signifying there. Then it says, and this is where it gets a little bit tricky, draw a Venn diagram to represent the sample space, event A and event B. So now this is the first time that we are going to have two different events in the same Venn diagram. So I start with a rectangle because that represents my sample space, okay? And then I'm going to have a circle or an oval, it doesn't matter what you make, and then another circle. Now, the reason that they cross over, okay, is you have to think about all of these different pieces. So if this is A, if this is B, and then my rectangle is my sample space, okay? I always start with what's in the middle. So this is what do both of them have in common. So I look at my two lists and what do they both have in common? Well, they both have an RR and an FF. Okay, so my RR and FF both need to go in the middle. Okay, then I move on to thinking about what does each one have that the other one doesn't. Okay, so B has this RF and FR left over, so I need to put RF in B and FR in B, but not in A. And then A has this WW left over, so I'm going to put WW in here. Now you're not done there because you have a full sample space. So we haven't done the whole sample space. So what we have to look at is we've already written WW in, we wrote RR in and FF in, and then we wrote RF and we wrote FR in. Everything that's not underlined up there needs to go in the sample space. So I can put, and you can put them anywhere you want as long as they're in the sample space, but not in A or B. So WR, WF, RW, and I kind of ran out of room there, so FW. Okay, and that's going to be your Venn diagram for this situation. Okay, so express, this says A intersect B in set notation. So where is the intersection? So we remember when we have two circles, the intersection is where they cross over. So we say that A intersect B equals, put the curly brackets, that's set notation, and then you're going to put RR and FF in those curly brackets. There's two things in that set. Okay, to talk about A union B, okay, it's in one or the other. We put them together. We're going to list everything that's listed in here, but only once. So I'm going to go from left to right, WW, RR, FF, RF, and FR. Okay, essentially what I did is I just listed anything that was in either of those circles, okay, including the middle there. So that's my intersection and union. Make sure you go over those. If you have questions on those, please don't hesitate to ask about them. Okay, so this is not on your paper, but figures 4A and 4B show two events, A and B. In each figure, a region represents the combination of these events is shaded. Okay, so which one of these figures shows an intersection? Think about that in your head. And which one shows a union? Okay, think about that. So the intersection is for B and the union is for A. Hopefully you got that right, but those are the ideas there. Again, the intersection is where do they both occur, and the union is where do one or the other or both occur, and that's the or. Okay, return to the situation involving rolling two die from question 1. Okay, so I'm going back to actually question 2. Let A be the event that the sum is less than 6 and B be the event that the sum is even. Okay, so what you end up with that, if you take that question number 2 and you go through and you change it, okay, is you end up with a Venn diagram that looks like this. Okay, so in the one that we talked about, we had event A be any numbers that gave a sum that was less than 6. Okay, and then now we have an B in the event that the sum is even. So what do we have in the middle is any of the numbers less than 6 that are also even. So we have 2 and 4 in here. Okay, What do we have just in A over here is any of the numbers less than 6 that are not even. Okay, so we have 3 and 5 in this set A over here. And then what do we have in set B over here is we have any of the numbers that are even but are not less than 6. So 2 and 4 were here, so we just keep going from there. 6, 8, 10, and 12 is what you see in B. Okay, so then the part that everybody misses is what is left over. Okay, you go through. 1 is not a part of the sample space. 2, 3, 4, 5, 6, 7's not in there. 8, 9's not in there. 10, 11's not in there. And then 12. And so that's what makes up my sample space that's out there. Okay, so use that Venn diagram to identify these. So go ahead and pause the video, try these out, and then come back and see how you did on these different things. Okay, event A, even though I'm looking at this Venn diagram and it looks like it's 3 and 5, realize event A is this whole circle. Okay, so event A is 2, 3, 4, and 5. Okay, A intersect B, where do they cross over each other, is 2 and 4. And notice I'm using set notation. Okay, A union B is where are both of them at. Okay, you can go in order if you want to, however you want to do it, but that's going to include 2, 3, 4, and 5, and then 6, 8, 10, and 12. Okay, if you wanted to do 3, 5, 2, 4, 6, 8, 10, 12, it doesn't matter the order as long as you get all of the correct elements. Okay, so what is the complement of A union B? So that means anything that is not in A union B. Notice we just did A union B, okay, and this means not. So not in A union B is going to be your 7, 9, and 11, all of those numbers that are outside of the two circles. Okay, now this one's a little bit more tricky, so I'm going to use some shading and stuff to show you this. But what this one is suggesting is that you do the complement of A intersected with B. So the complement of A means anything not in A. So not in A is going to include all of these pieces. Those are not in A. Realize 2 and 4 are in A. Okay, intersected with what is in B. Okay, so what is in B in this case is the 2, the 4, the 6, the 8, the 10, and the 12. Okay, how do you find an intersection? You find any of them that you highlighted twice. Okay, so this one is going to be 6, 8, 10, and 12 for your answer. Okay, again, if there's questions, please don't hesitate to ask. Okay, so back to your paper. Go ahead and finish the last question on your paper and then come back to this. I'll give it about a 5-second break here. Okay, so residents of the U.S. who are legally allowed to work are assigned a social security number. So this is real information here. You randomly select a student from your school and record the last digit of his or her social security number, provided that he or she has a social security number. Or you can record no SSN if the student does not have a social security number. Okay, find the sample space. Okay, so the sample space in this case is going to be 0, could be a 0 at the end, 1, 2, 3, work through your single digit numbers all the way up through 9. If you stopped there, you missed something, because realize that some people will not have one, and they said to record no SSN if that was the case. Okay, consider these events. I'm going to go ahead and write my set notation off to the side of these so that I can see them a little bit better. The student has a social security number, so that takes away the no SSN, and the last digit is even. Okay, so if we're talking about our even numbers here, last digit being even, we're going 0, 2, 4, 6, and 8. Okay, the last digit is odd. Okay, again, not no social security number. So we have 1, 3, 5, 7, and 9. And then the last digit is greater than 4, greater than, not equal to. So we start at 5, 6, 7, 8, 9. Okay, those are my A, B, and C events. So draw a Venn diagram using 3 circular regions to represent events A, B, and C. Okay, so when you do a Venn diagram with 3, you've got to be a little bit careful because you have to overlap everything slightly. So you need to do an oval however you need to do it. But so these two need to overlap, but you also need this third one to overlap each of them individually and all of them together. Okay, so something like that is what you need to draw in. So I'm going to just call this event A, event B, and event C, and I'm going to label them there so that I know what they are, and then see what we can list. Okay. So we're putting everything from the sample space. So I look at 0, and you can do it this way if you want to. 0 is in A, it's not in anything else, so I'm just going to put it in A and not in anything else. Okay, 1 is in B, but not in anything else. 2 is in A and nothing else, so I'm going to put it in A and nothing else. 3, if I look at this, is in B, so I'm going to go down to B. 4 4 is in A and nothing else, so I'm going back to that A. 5, my next number there, is in B and C, but not in A. So I want to find where B and C cross, but not A, and this is where I'm going to put my 5. Okay, 6, my next number there, is in A and C, but not in B. So I find A and C where they cross, but not B. It's right here. So that's going to be 6. 7 is in B and C. So we have that one here as well. 8 is in A and C. So we have that here. And then 9 is in B and C. So that also goes in here. And then remember, we have that no SSN, which is going to be in none of these events. It's going to be out here. So no SSN goes in the sample space. Okay. Do notice that there is nothing in only C. There's nothing in all three of them, and there's nothing in only A and B. Okay. So those are what you see there. So then can you answer these questions? Okay, where's A intersect C? So where do A and C intersect? Okay, and that's going to be in this entire area here. So realizing in this one that we don't have other information there, but it's just 6 and 8. Okay, but it could possibly be other pieces of information there. Okay, if we talk about A complement, okay, anything not in A. So look at this red circle, cross it out. Okay, and then look at everything else. So everything that's not in there is the 1 and the 3, the 5, the 7, and the 9, and then the no SSN. Okay, we keep going. A complement intersects C. Well, I just wrote A complement, okay, and my C's up here. So what do they have in common? I can just look through the list. So 1, 3, not in C, 5's in C, okay, 7 and 9 are in C. So I have my list of A complement intersects C. If you want to do it from the Venn diagram, A complement means that you cover up your A that's there. This is going to be hard to do, but I want to try to give you a visual of this. So you cover up your A, so you would cover up these, so what's not in that, and then what intersects with C. So this is what's in C, so that's what intersects it, okay? So you can use a cover up, and it doesn't work perfect here, but that's the idea, okay? B union C means look at all of B and all of C and write everything down once. So if I look at those, I have the 1 and the 3, I have the 6 and the 8, and I have the 5, the 7, and the 9. Again, you do not have to have them in numerical order. And then lastly, we just did B union C, so what's the complement? Essentially, look at this list, look at the sample space, and list everything that's not in the sample space. So 0, 1's there, 2, 3's there, I can do 4, 5. Oh, 5's there, so we cross that out. 6, 7, 8, 9, and then we have no SSN. Okay, and so you can follow what you have there. Okay, so that is what we have for today. You do have a homework worksheet for today, so go ahead and go through that. Just like homework when we were in class, all of the homework for today's stuff is on Google Classroom, so you can look at the answers. And if you have questions, please don't hesitate to ask me.